Okay, so I'm going to take you through a couple of the questions from the homework and kind of work you through it. And then you're still expected to do all of the problems. So do make sure that even the ones that we don't go through here in this little video, you do the rest of them as well. Okay, so there are the three different numbers that we'll use for R. There's one of them is repeated because, of course, millimeters of mercury and torr are synonymous. They're the same thing, so therefore they have the same R value, 62.4. But we want to make sure that we have that right before we get started, because if you have the wrong R value, you're never going to get the answers correct. So the first thing I want you to do is write down the ideal gas law for each question, PV equals nRT. And I want you to go ahead and rearrange this first one to solve for what you think the question is asking for. Okay, so there's the equation that you should have come up with, N equals PV over RT. And now it just becomes a matter of plugging the numbers in. Don't forget to pay attention to which R value you're supposed to use based on the pressure that you're given. And don't forget to convert your temperature to kelvins. And then go ahead and come up with an answer. Okay, so you should have gotten 0.12 moles of oxygen. The only kind of sticking points might have been if you didn't use the right R value, because we are in atmospheres, which means we have to use the R value that has atmospheres in it, which is 0.0821. Also, if you didn't take your temperature, 25 degrees Celsius, and add 273 to that to get 298, that could have messed you up. And the other thing would be on your calculator, if you're going to try to enter this all at once, you do need to make sure that you have one big set of parentheses around that entire denominator. Otherwise, the calculator doesn't know how to do the order of operations correctly. Okay, let's go ahead and do number 3 together. We're looking for volume, so go ahead and rearrange PV equals nRT to get V by itself. Okay, you should have divided both sides by P, which means that V equals nRT over P. And so N is 2.0 moles. R, because we're in torr, is what number? Okay, you should have said 62.4. Torr times liters over moles times kelvins. And then temperature, if I'm at 20 degrees Celsius, that would be 293 kelvins. And then pressure is 720 torr. Okay. Go ahead and plug this in and see what you get. Okay, you should have come up with 51 liters. It was actually 50.786, repeating, but rounded to 2 sig figs, 51 liters. Notice too, I didn't mention this in the previous problem, but notice what cancels: moles, torr, and kelvins, which does in fact leave you with liters, which is the unit for my answer. I'm gonna skip over the next couple because they're not that different. We're just rearranging the ideal gas law differently. I do want to say about this next one, or actually the next couple, if volume is in milliliters, don't forget to divide by 1,000 and convert that to liters. But let's go ahead and jump all the way down. And I do want you to do all these, by the way. All 8 questions should be done when you come to class next time. But let's go ahead and jump all the way down to the last one. So number of grams of CO2 that exert a pressure of 785 torr at a volume of 32.5 liters and a temperature of 32 degrees Celsius. So we're being asked for grams of CO2. And we did a problem like this in class. But just to see if you remember how to do it, if we're looking for grams of CO2, what variable in PV equals nRT is the closest thing to mass? It's not mass directly, but it's the closest thing to mass. Okay, so you should have said moles, N. So we're going to be solving for moles, then converting to grams. So go ahead and rearrange your equation and solve for moles. Okay, so you should have ended up with 1.34 moles of CO2. And the big reminders there were, again, making sure you have the right R value, given that our pressure is in torr. And then also adding 273 to our temperature, which was 32 degrees Celsius, which leaves us at 305 kelvins. So from 1.34 moles of carbon dioxide, let's go ahead and see if we can figure out how many grams that would be. Okay, and there you have it, 59 grams of CO2. Just use the periodic table to go from moles to grams. So again, don't forget to do the rest of the assignment, the other problems that I didn't go through, and I'll be checking those next time. Make sure you come to class with questions.